Another identity is that the cosine of pi over 2 minus theta equals the sine of theta. In fact, the proof for this is very, very straightforward, so it might be worthwhile to go over it. There we have the cosine of pi over 2 minus theta, which is the cosine of the first times the cosine of the second plus the sine of the first times the sine of the second. What is the cosine of pi over 2? 0. So I have 0 times the cosine of theta. That's going to be 0. What's the sine of pi over 2? 1. So I have 1 times the sine of theta is the sine of theta. So that's why it works. The other one is pretty straightforward as well. The sine of pi over 2 minus theta. What I'm going to do here is essentially treat this like some angle alpha. Is that okay with you? And so I'm basically saying that this is going to equal the sine of alpha. Now, we just showed that the sine of some angle is equal to the cosine of pi over 2 minus that angle. Agree? So this equals the cosine of pi over 2 minus alpha by this theorem right here, or that identity right there. Do you? But alpha is pi over 2 minus theta. This is your alpha right here. Right? So I have pi over 2 minus pi over 2. That's going to be 0. And then a negative make a positive. So I'm left with just the cosine of theta. So that one's proven as well. I'm going to continue to use these, and now what I want to do, let me mark this off, is figure out the sine of alpha plus beta. Okay? Well, the sine of alpha plus beta, I'm going to treat alpha plus beta as theta. And I'm going to rewrite this as the cosine of pi over 2 minus that alpha plus beta. So again, I'm using this identity right here. Theta is alpha plus beta. You see that? And I can just rearrange these as the cosine of pi over 2 minus alpha minus beta. Like that. And I'm going to treat this as one angle. So now I have the cosine of the difference of two angles. That will be the cosine of the first, which is pi over 2 minus alpha, times the cosine of the second, plus the sine of the first, times the sine of the second. Remember that? Now the cosine of pi over 2 minus alpha is going to be the sine of alpha times the cosine of beta. The sine of pi over 2 minus alpha is going to be the cosine of alpha. And then the sine of beta. So now we have that the sine of alpha plus beta is the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. In words, the sine of the first plus the second is the sine of the first times the cosine of the second plus the cosine of the first times the sine of the second. The sine of the sum of two angles is the sine of the first times the cosine of the second plus the cosine of the first times the sine of the second. And by the way, if we want the sine of alpha minus beta, what I would do is write that the sine of alpha plus negative beta. And that's going to be the sine of the first times the cosine of the second plus the cosine of the first times the sine of the second. Cosine of negative beta is the same as cosine of beta because the cosine function is even. And then the sine of negative beta is negative sine beta, so that's cosine of minus cosine alpha sine beta. So now the sine of alpha minus beta is the sine of alpha cosine of beta minus cosine alpha sine beta. I believe I have all this on the next slide for you. There it is. And remember, if you want to write this as one formula, this is a little different than the sum or difference of two cosines. Here, when you got a plus in between here, you also have a plus over there. Minus here, minus there, which is opposite or different from the cosines. We're going to find the exact value of the sine of 19 pi over 12. Same idea as it was for degrees. We would like to find two special angles whose sum or difference is 19 pi over 12. Need some help remembering your special angles? It might even be helpful to rewrite these special angles so the denominator is 12, right? Pi over 2, which is what, 6 pi over 12, right? What else do we have? 2 pi over 3, which is going to be 8 pi over 12. And then we have 3 pi over 4, correct? Which is 9 pi over 12. Are we getting close here? There was 5 pi over 6, which is 10 pi over 12, isn't it? Lo and behold, 9 pi over 12 plus 10 pi over 12 gives me 19 pi over 12. So you might want to say that the sine of 19 pi over 12 equals the sine of 3 pi over 4 plus 5 pi over 6. I have the sine of a sum. So that's going to be what? Should I rewrite this for you? Sine of alpha plus beta, sine of the first, cosine of the second, plus cosine of the first, sine of the second. So we're going to have sine of 3 pi over 4 times the cosine of 5 pi over 6 plus cosine of 3 pi over 4 times sine of 5 pi over 6.
So it's going to be negative root 2 over 2 times...
What's the sine of 3 pi over 4?
Or root 2 over 2.
Positive square root of 2 over 2. Cosine of 5 pi over 6. Sorry? Is this going to be subtraction? This here? No? When it's the sine, when this is a plus, this is also a plus. When it's a cosine, it's the other way around. Okay? Cosine of 5 pi over 6 was what?
Negative root 3 over 2.
Okay, very well. And the cosine of 3 pi over 4?
It's negative root 2 over 2.
Negative root 2 over 2. Sine of 5 pi over 6? 1/2. And so I have negative root 6 over 4 minus root 2 over 4, which is negative root 6 plus root 2 over 4. Parts A and B is material that we've learned earlier, isn't it? Yeah, and we can obtain the value of cosine of alpha in one of two ways. Way one would be to use the definition of the trigonometric functions. Way two would be to use identities. How about for part A, we use the definition, and for part B, we use the identities. That way you can see both. Sound like a plan? Very well. So for part A, we want to find cosine of alpha. We know that sine of alpha is 3/5. And by definition, sine of an angle is y divided by r. Right? And so here we have that y is 3, and therefore r is 5. We also know that x, y, and r are related through x squared plus y squared equals r squared. So x squared plus 3 squared equals 5 squared, right? So x squared equals, let's see, this is going to be 25 minus 9 is 16. So x is either going to be a positive 4 or a negative 4. How do I know which? Well, here alpha is in the second quadrant, right? And in the second quadrant, the x-coordinates are negative. Alpha in quad 2. And so cosine of alpha is going to be x over r. So that's negative 4/5. You remember doing that? Let's do part B, but this time we'll use trig identities. How does that sound? Lovely. We know that sine of beta and cosine of beta are related through the Pythagorean identity. Cosine squared of beta plus sine squared of beta equals 1. Well, we know sine of beta is negative root 5 over 5. squared plus cosine squared of beta equals 1. This is going to be 5 over 25, or 1/5, yes? Plus cosine squared of beta equals 1. So cosine squared of beta is going to equal 4/5. Subtract 1/5 from both sides. So cosine of beta is plus or minus the square root of 4/5. Do I choose the plus or the minus? How do I know I choose the plus? I am in the fourth quadrant where the cosine function is positive. So I have 2 over the square root of 5, which is 2 root 5 over 5, and there you have it. Does this make sense? So now we have cosine of alpha and we have cosine of beta. All we need to do next is figure out cosine of alpha plus beta and sine of alpha plus beta. Ready to give that a whirl? So again, we know cosine of alpha is -4/5. And we now know cosine of beta is two root 5 over 5. So for part C, if we want cosine of alpha plus beta, what's that formula? Cosine of the first times the cosine of the second minus sine of the first times sine of the second. Cosine of alpha is -4/5. Cosine of beta is 2 root 5 over 5. Sine of alpha is 3/5. Sine of beta is -root 5 over 5. So let's see, I have -8 root 5 over 25 plus 3 root 5 over 25. So that's going to be -5 root 5 over 25. Is that right? Which is -root 5 over 5. How interesting. How many think they could do sine of alpha plus beta? Sine of alpha plus beta equals
Sine of the first times the cosine of the second.
That's right. Sine of alpha is 3/5. Cosine of beta is 2 root 5 over 5. That's a 5. Plus cosine of alpha is -4/5. Sine of beta is -root 5 over 5. And so here we're going to get 6 root 5 over 25 plus 4 root 5 over 25 is 10 root 5 over 25, which is 2 root 5 over 5. We could prove that the tangent of alpha plus beta is equal to the tangent of alpha plus the tangent of beta divided by 1 minus the tangent of alpha times the tangent of beta. The proof is relatively straightforward. All we need to do is rewrite this in terms of sine alpha plus beta over cosine alpha plus beta, and then do some simplification. That's done for you in the book. Right, what we have going on here is when we're adding the angles, the numerator is adding the terms and the denominator is subtracting. Whereas here, if we're subtracting, the numerator subtracts and the denominator adds. So, for example, if I said, what does the tangent of 2 pi minus theta equal? That would be a utilization of this formula right here. That's going to be the tangent of 2 pi minus the tangent of theta over 1 plus the tangent of 2 pi times the tangent of theta. By the way, one other issue that you need to concern yourself with is neither alpha nor beta can be an odd integer multiple of pi over 2 when utilizing this formula. Reason being is the tangent function is not defined at odd integer multiples of pi over 2. Remember, that's where the vertical asymptotes are on the graph. What is the tangent of 2 pi? 0. Right? Because tangent of an angle theta is y divided by x. Y divided by x. And so the angle 2 pi would have a terminal side on the positive x-axis, which is where in the y-coordinate is 0 there. So I have 0 minus tangent of theta over 1 plus tangent of 2 pi is 0, so I have over 1 plus 0. So this is going to equal negative tangent of theta.